Sophia, are you outside?
Yeah.
That's so cool. Is it nice outside?
Yes.
I'm gonna go for a bike ride when I get done. I'm tired. This is like late stay for me working late today. I got here early and staying late. I don't know. I don't know what that means.
How comfortable of a bed it would make. Part 11, here's the top 5.
Oh, top 5 of what? Top 5. Top. All right, Lily. All right, I'm going to take roll. Just give me a holler if you're here. Raina.
Here.
Zach.
Here.
Alexis.
Here.
Caleb.
Here.
Aragama.
Here.
Gabe.
Here.
Lily.
Here.
Becker.
Here.
Reason.
Here.
Karina.
Here.
Diplomatic.
Yeah.
Ella.
Here.
William.
Here.
Bailey.
Here.
Sophia.
Here.
Jaden.
Here.
Morgan.
Here.
Jordan.
Here.
Audrey.
Here.
Hope.
Here.
Alrighty, everybody's here. Awesome. So here's what my life has been like. So I used to get, pre-COVID, I could get a quiz, all the quizzes done in 2 hours. It now takes me 2 days. I just finished up I didn't have lunch. I just finished up getting them done. So everybody has their scores. I haven't emailed you my handwritten score. Do you know what I mean? So if you took it in place, that's going to come to you. And I was hoping to do it during lunch, but I had like 3 people to do, and I just did it. I just got those done. So that'll be done tomorrow morning, okay? So as you go through that, if you have any questions or disputes, you can just text me or email me, and I will carry on some type of communication with you, and we'll make the appropriate adjustment. Does everybody understand that? The other thing you may have noticed is you got a Zoom thing for Wednesdays. So from 8:30 to whatever, it's your opportunity to stop in, ask me questions about what we're doing. Like next Wednesday, we have a test. So if you need feel you need some more practice or better explanation to get ready for the test, you can use that opportunity to do that if you wish. I am going to write the test in such a way that the majority of people would be able to finish it in about 50 minutes. Does that make sense to everybody? Okay, so I'm gonna have to like Tuesday stay up all night so I can get that quiz done. So that's what I'm looking forward to do Monday night. So what I'm going to do is go over the quiz that you took, and then I'm going to work on this packet that is, give you some packet. You have 2 problems that are going to be due Friday by 8 a.m. And I assigned that, and attached to it is the packet. And I know some of you picked the green period 1 people picked it up in class yesterday, but it's to everybody now electronically. Okay, but that has to be submitted to me by 8 a.m. and it says that on there. Okay, but I'm going to go through some of that today so you kind of know what's going on. All right, I'm going to attempt to share my screen, and I need to do something first. So just bear with me. I see it right here. All right, we're in good shape. You guys see this, right?
Yeah.
Yeah, okay, good. All right. All righty, so here I go. And if you need a clarification, you can just give me a holler and I will do that. So this is a piecewise graph. And since there's 3 pieces, it's worth 3 points. And what I do is I start at 2 here. I'm going to go 1, 2. And I'm going to plug 2 into here, knowing that I can't have a point there. And I'm going to get, if I plug 2 in there, I get 4. 4 minus 3 is 1. So I have an open circle at 2 comma 1. And then what I'm going to do, I know it's a parabola that goes up. And so if I put in 0, I get a negative 3. And the reason I do that is so I can kind of, God, that's lousy. I apologize for my art. It sucks. I'm sorry about that. Someday I'll tell the story about how I failed coloring in kindergarten. So the point that is defined is 2 comma 3. 1, 1, 2, 3. So I'm going to put a dot there. And then over here is my third part. If I put 2 in there, I also get 1. And so I'll have an open circle. And 1, 2, 3. If I put 3 in there, I will get 6 minus 3. So I have a graph that looks like that. And it's has a hole. And so this is 1, 2, 3 points. And it says using the graph from problem number 1, find the limit. And the limit as x goes to 2 of f of x is equal to 1. How do I know that? I have to say that the limit as x approaches 2 from the left of f of x is equal to the limit as x approaches 2 from the right of f of x, and that limit is 1. So you could write that out in words. You had to have all of this to get 1 point. If you had this and didn't have that, I think I gave you a half a point. But if you had this without that, I took off the whole point, because that's how important the justification is. Any questions on 1 or 2? Number 3 was worth 4 points. First of all, f of -3 is defined. 1, 2, 3, -3, I have here at 0. And f of 3 is also defined, so I have those. So I had to make sure that that happened. Those are 2 points. The limit exists, so that means it's continuous at that point. And over here it doesn't exist. So this is what I did. I had something that looked like that. And so I just checked, did you have each of those? You could not have single points. It had to be a function. I needed parts to it. I couldn't, yeah, it had to be a function. Any questions on the front page? So this is 1, 2, 3, 4, 5, 6, 7, 8. And if I go to the back side, I gave you this graph, f of a -2. Okay, so here's a -2, because here's 5, 4, 3, 2, 1, 0, -1, -2, and that's going to be a -4. It's defined. However, the limit is not defined because I can't approach it from the right. It only has a left-handed, excuse me, I can't approach it from the left. It only has a right-handed limit. F of 0 does not exist because it's open, but it does have a limit that is 0. F of 3, 1, 2, 3 does not exist, and the limit does not exist because it's different as you approach from the left and the right. F of 4 is right there. And so I think I said that was, what did I say F of 4 was? Oh, excuse me. F of 4 is right here, not there. F of 4 is right here, so I said that's 0, and the limit's also 0 because it's continuous at that point. So what you can do when you check yours is you can watch this video. I have a couple of videos I gotta post. What it does is when I'm done with Zoom, it takes a while for it to convert an MP4, and then I put it on Schoology. So that's
I have a question really quick. Is that all right?
yeah, of course.
All right. So for letter C, f of 0, it looks to me, is there not a 0.2? Like if you look at f of 0 and then you look.
Excuse me, f of 0, yeah, there is one above there. I agree with you. F of 0 is 2. You are right.
Okay. Thank you.
You are correct. I was wrong. So I will check everybody's work to make sure I designated that.
Thank you.
No, thank you. So I'm going to rewrite that. Yeah, so William, I always appreciate more work.
Thank you.
Anybody else? And if I don't make the adjustments, make sure you email me or text me and say, hey, I need that additional point. So that was 16 for the front part. Here's the second part. And the second part, when I plug those numbers in, this is what I got. Oh, I have to talk about this too. 0.593. Now, if I go to the machine here, let's see what I have here. Yeah, I have this very one. So I'm going to go, can you guys can see my calculator, correct? So if I go to my menu and look at my table, and I type in 1.99, I get this. This is not a negative number. This means you got 6.3, you're gonna move this decimal point 3 places to the left. So 3 places to the left is 0.0063. It was here, now that decimal moves here. It got smaller. This is scientific notation. It means 6.3 times 10 to the negative third. You guys learn scientific notation, don't you? Okay. Down here then, I'm going to put in 1.999, and that gives me, now that decimal has to move 5 places to the left. So I got 0.000063. So it started here, moves 5 places to the left. So you can see this is getting smaller. There's no value for that, it's not defined. When I plugged in these numbers, I got 0.689, 0.0064. I'm going to type this one in, 2.001, and I get 0.000064. So what is this approaching? This is approaching 0. Okay, and I think there was a typo in here, and I said, hey, you got to replace it with this. This needs to be a 2. So people had to follow those directions. All right, right here, I'm going to graph this. So if I graph this, here is 1, 2, 3, 1, 2, 3, 4. And this is about 2.718. So this is dropping down, getting closer to this E plus 1, and it exists. So I'm going to 1, 2, 3, I'm going to say it's about there. And I'm just going to have it drop down like this. And this one is rising as it comes from the right to the left. So, and it's headed towards 1. So that means there has to be an open circle here, and it's headed like this. So that's the graph I was looking for. And what is the limit? I had to make sure I had this, and that does not exist. So this was 1, this was 2, this was 3, this was 4 points. Next page. I just had to plug in 2, raise to the first power, and I get 3 as my answer. I had chosen a different number, but since the answer was 3, I didn't feel like I wanted to change that. So on this one, I have to multiply by the conjugate. And that's going to give me x plus 25 minus 25 over x times the square root of x plus 25 plus 5. I'm going to do this computation. That's 0. X plus 0 is x. When I simplify that, I get 1. So I'm going to rewrite this limit as a limit as x approaches 0 of 1 over the square root of x plus 25 plus 5. When I plug that in, I get 1/10. So the way I would correct this, if you knew to multiply by the conjugate and could not do anything else, I gave you 3/10 of a point. If as you did your work, you did an algebraic mistake, I took off 3/10 of a point. If you do an arithmetic mistake, if you did some arithmetic that was wrong, in other words, You took 5 plus 5 and got 25. I took off 0.2 of a point. But if you did things like on this next one, you got to distribute the minus sign. If you did that incorrectly, I took off 0.3. Because that's a bigger issue and it's going to be more, having more problems as opposed to if you do some type of computational mistake. They're not nearly as harsh on that as they are on the algebra. Does that make sense to everybody? So when you see that, you can take a look and say, hey, I'm going to watch the video. What in the heck did he say about how he graded? So if you have some dispute, you can talk to me about that. So the common denominator is the product of these two. So I'm going to multiply this first fraction by 7 on top and 7 on the bottom. And on the next one, I'm going to multiply by x plus 7 on top and the bottom. And here's where there are a lot of people that made a number of mistakes in that they did not distribute this minus sign through correctly. So on this, I get 7 minus x minus 7 over x times x plus 7. That's 0. X minus 0 is, excuse me, a negative x minus 0 is a negative x. That simplifies to a negative 1. So now that means I'm going to take the limit as x approaches 0 of a negative 1 over x times x plus 7. And that's going to give me a negative 1 over 49. So if you would have gotten a negative 1/14, you would have lost 0.2 of a point. If you got a positive 1 over 49, you would have lost 0.3 of a point. Okay, so now what we have is two variables, h and x. I'm going to use the same method. So I'm going to have 3x minus 3 times x plus h over x times x plus h, all that divided by x. And so that's going to give me 3x minus 3x minus 3h over x times x plus h multiplied by, this should not be x, this should be h, 1 over h. So again, I have some simplification going on. That's 0. 0 minus 3h is a negative 3h. When I can simplify these h's, I'm left with a negative 3. So this limit becomes the limit as h approaches 0 of a negative 3. That h is not there. That was a common mistake. The people would cross that out, but then they'd rewrite the h. And down here, I'm going to have x times x plus h. The only thing I'm affecting, the only thing I'm changing is h, and I'm forcing it towards 0. And since I can plug 0 into here, and I don't have to worry about what x is, I'm going to get this as my final answer, a negative 3 over x squared. The next one, I got to square this. When I square 2x, I get 4x squared. Here was a common mistake. I'm going to have 2x times delta x, which gives me 2x delta x. And then that's one side. And then the other side is going to be delta x times 2x. That also is going to give me 2x delta x. So that is 4x delta x plus delta x squared minus 4x squared all over delta x. So the mistake for some people is they had 2x here rather than 4x. This becomes 0. I factor out both terms have a delta x in them. I factor that out. I get 4x plus delta x over delta x. I can simplify that. So now I have this equal to the limit as delta x approaches 0 of 4x plus delta x. This is going to become 0, and I get the expression 4x. And to be honest with you, the number of people that had limits correct was amazing. I've never had such an amazing group that did so well on this section. You guys should be very proud of yourselves. And even the ones in which people got wrong, it was just some tiny, tiny, tiny mistake that you made. So here you have to multiply 2 times a -5, which is a -10 and squared, and I got 100. I was really happy that no one gave me a -100. Here I'm going to add them together, and I get a -3. So this was 1, 2, 3, 4, 5, 6, 7. So that part was 11 points. So both parts together gave you 27. And so what I'm going to have to do is kind of go over your quizzes again. And so you're going to see some adjustments because of the fact that I had a dot on the previous page. On the calculator free part, right here, I had this dot. And I'm the one that put it in there, and then I forgot about it. So I will fix that and make that change. So you should see an adjustment by tomorrow with that change. Okay? All right, because I'm sure there are people that wrote 2 there and I marked it wrong. Any questions on that at all? None? All right. Well, I handed this out to some people yesterday. And everybody, and I'll share this again with you. And I have attached this to the assignment that's due Friday. I know a couple people said, hey, you said there was an assignment due Friday. Do you have that available? And I wasn't able to get it to you last night, but I just got it to you this morning. Okay. Did I talk about this? The Tucker, Grayson, well, the rest of you. Did I talk some of this yesterday? I did, didn't I?
Yeah, you did.
Okay. So one of the big questions, one of the things they really check you is how well you understand what's called the intermediate value theorem, excuse me. And what you notice, the very first system thing is that it's used to prove that there's some y value. And the idea is it's continuous. And if I go from one point to another point and draw a continuous line, I have to hit y values that are between those 2 points. That's the idea behind that. And I'm just going to repeat this particular example and then go through the examples that are on here. Again, you can take a look on the video later when you do this. And I'm going to show you what I want you to do and what 2 problems you're going to do on this sheet. Again, that's due 8 o'clock Friday morning. So here's an example. Here's a function, and the function is the product of negative e to the x and the cosine of x. And it says, show without using a calculator that there exists at least one 0 on the interval 0 to pi. Now this is a closed interval, and these are x values. This 0 is a y value. In fact, if you look on a TI, and I don't know if I showed you this because I get confused. If I go to second calc, on line 2, there's this word 0. Well, it's the x-intercept. It's where the function crosses the x-axis. It's where y is 0. And so that's what they're asking you about. So to do that, you're really going to do 4 parts in your justification. Your first part is this. You have to say something about the function that's very important, even if it's stated in the directions. You need to say the function is continuous. And it says it right here in this particular statement. It sometimes it doesn't state that it's continuous, and you have to justify why you know it's continuous. And I'll talk about that some more on Thursday, tomorrow. The next part, so this is part number 1, is just say that it's continuous and what interval it's continuous on. And then you have to state your y values. So you take the left endpoint of the closed interval and you plug it in the function. And when I do that, when I plug it into this function, I get negative e to the 0 power, which is a negative 1, times the cosine of 0, which is 1. And that's why this value is a negative 1. And if I plug, so that's below the x-axis. When I plug in 0, I'm below the x-axis. I'm on the y-axis at a negative 1. And when I plug in pi, I'm going to get 2.718 raised to the 3.14 power approximately. So that's a positive number. That's a number above the x-axis, which means this is, the second part is this line right here. So you have to say, hey, I've got this special value, this 0, falls within these 2 y values that I computed. This is the third part. So there must exist where this is true. There must be a C. There must be a C in this interval where if I plug it into F, it'll give me 0. How do I know that? And here's the very short fourth part by IVT, because it's continuous. So if I were to draw, a lot of times I also draw a graph. So I draw one endpoint and it's 0, negative 1. Here's 1, 2, 3. So pi is about here. E to the pi power is about there. And I've got to go from here to here. So here's 0, here's pi, there's my interval. And I don't know, I could go there directly. I could have a little curve to that. I could have another little curve to that. I could go this way. But any way I go with any of these examples, notice I'm having it's continuous. I've got to cross somewhere between this interval. I have to. Why? Because I cannot pick up my pen going from this point to this point. How do I know that? Because it's continuous. That's the intermediate value theorem. So let's take a look at another one. Here's one from an AP test. It's multiple choice. And it says, notice it says, let F be continuous. Selected values of F are given in the table below. Now, there are 1, 2, 3, 4, 5 selected points. Here's my X values. Here are my Y values. I do not know how these Y values were computed. I just know when you plug in 1 into F, it'll give you a negative 2. When you plug 8 into F, it'll give you 7. And it says, what is the least number of solutions does the equation f of x equals 1/2 have on that closed interval? So it's asking you how many C values are there that'll give you a half. One way to do that is this. And you don't have to do it this way, but I'm a visual person, and maybe some of you are also. So I'm going to plot points. There's 1, negative 2. Here's 2, 3. Here's 3, 1. Nothing at 4. Here's 5, negative 5. And here's 5, 6, 7, 8. Here's 8, 7. And it doesn't have to be scaled appropriately, but what I'm going to do here is I'm going to connect the dots, just like you used to do at Perkins. and it's continuous. There's no breaks in it. Okay, where is my function equal to a half? Well, it's equal to a half all along here. So how many places? Here's a C that could give me a half. Here's a C that could give me a half. Here's a C that could give me a half. I have 3 of those that could give me a half. The least number of solutions that make that a half are 3. Now, some people are far more analytical, and they say from negative 2 to 3, I had to go to a half. But from 3 to 1, I don't, because I'm above a half. From 1 to a negative 5, I had to cross a half. And from negative 5 to 7, I had to cross a half. So you can look at it using the table also. Between these y values, because a half is a y value. Okay, I'm going to pause there. Does anybody have any questions? All right, I'm going to go look at this next problem here. And I'm going to pick Caleb. Are you all for a sport?
Yeah, I play sports.
What sport?
Hockey.
Oh, that'll work. Oh, I got another hockey player. Okay, what position do you play?
Defense.
Defense. Well, then I know you do this for sure. Do you ever skate forward?
Yes.
Do you ever skate backward?
Yes.
Okay. So you're going to ask what that has to do with calculus, but I'm going to talk about it in a second. Okay? So I'm
Okay.
going to be asking you some questions. Okay? It says, now let's look at a free response question, and we have to justify. So on the front page is my justification. If you remember, there are 4 parts. And William, I got a question.
What is it?
You swim, correct?
Yep.
Caleb plays hockey, correct?
Mm-hmm.
Both of you deal with water. I just thought of that. Do you ever swim backwards?
No.
Is it possible to swim? Oh, yeah. Yeah. Is it possible to swim backwards?
Yeah, it's just not very efficient.
No, but I think if I were in charge of swimming and diving, I would make a legal dive, the cannonball, and I would have a backward swim.
Well, do you consider the backstroke?
Yeah, I was just thinking about that. Is the backstroke considered swimming backwards?
Yeah, I would say that. Yeah, I would say you are swimming backwards.
Okay, so yeah, I do swim backwards then.
Oh, okay. No. Your feet would have to be first.
Okay, so no.
Yeah, you have to be, yeah. But if you would change, just reverse on the backstroke, reverse the direction of your arms. Wouldn't you go forward? I want you to think about it.
Maybe.
Well, back to Caleb. Okay, Caleb, what we have here is in this table, we have our input variable is time in seconds. So this, you got to remember, so this is on the x-axis, because sometimes we forget. And our function is a velocity function, v of t. So if you look, Caleb, that's why I chose you. I've got negative numbers here. I got a 0, and then I got a positive number, right, Caleb?
Yeah.
So what do you think the negative numbers mean?
They're or
Remember
like
the velocity. So this means a negative 10 feet per second, because they even tell you the units. A negative 15 feet per second. A negative 10 feet per second. A negative 7. A negative 5 feet per second. And then 13 feet per second.
So the negative would be moving backwards at that rate?
Yeah, so the negative means you're going in the opposite direction than the positive. Because the negative symbol just means opposite, correct?
Yes.
It just means you're on the other side of 0. So if you think about it, this would be like you skating forward. This would be like you skating backward. Oh, you with me on that? Caleb?
Yeah.
Okay, now Caleb, you're skating backwards. And then all of a sudden you're skating forwards. So somewhere you had changed direction. And you're trying to do it as quickly as possible, right? Because you're in a hockey game.
Yeah.
So did you stop?
No.
I think you did. I think you have to stop momentarily to change your direction.
Okay.
Very, very, very quickly. I'm talking less than a millisecond changing direction. Because don't you have momentum going one way and all of a sudden you got to switch your momentum going the other way?
Yeah.
Yeah. And I think that's what that zero is. It's a spot of changing direction, going from backward to forward. Okay. So I am going to pick Lily. Okay, Lily? Are you there?
I'm here.
All right. So you're going to just do part 1 of our justification. It says, now let's work on justifying the free response question. It says, for the open interval from 0 to 60, must there be a time t where v of 2 equals a negative 2 feet per second? Your answer, yes or no?
Yes.
Yes, I would agree. So I'm going to write yes, and then I'm going to put our justification. Since, and you're only going to do part 1. Since what? And I can give you a hint if you want.
Yes, please.
Ooh, what was that noise?
That was just my notification.
Oh, okay. Since f is oh, excuse me, not f. That's what's screwing you up. Since v of t is, there I go. I'm sorry. Since v of t is what? And it says it in the direction.
Continuous function.
Yeah, is continuous. You are exactly correct. Is continuous on some interval. What interval? Actually, I got to have brackets according to the sentence. I'm sorry.
Would it have to like deal with something with -2?
Nope. It tells you what interval. What time did the chart start? What time did the chart end?
It went from 0 to 60.
You're right. It says during the time interval 0 to 60, v of t is a continuous function.
Okay.
Does that make sense?
Yeah.
There's part 1. Now they told you that, but you want to make sure you say it again. That's the very first thing. Okay? And the reason I'm having you do that, sometimes they don't tell you that. And if they didn't tell you that it was a continuous function, you have to say, hey, I know it's continuous, and this is why. And that's going to make more sense as we move on. Okay? You'll give a little bit more of a hint on Thursday. All right. Audrey, there's part 1. Part 2, we have a y value, and our y value is right here at -2. But I've got to come up with 2 y values. I'm going to say v of what equals what first for my beginning of my second part.
Would it be v of 0 equals -10?
It would be exactly. And v of
6 equals 13.
equals 13. So now I'm going to say V of 0 is what?
-2.
Less than or equal to -2, and then I'm going to have,
Less than
sorry,
less than or equal to v of 60.
correct. So this y value is between these two y values, and it is, isn't it? Right?
Yep.
I probably shouldn't put a period. So there exists Tucker. There exists a what?
Y value of -2.
Now we're answering the question. And I think, Audrey, you were the first person, right?
You mean the person who answered the second?
Oh, the second. Who was the, oh, who was the first, who was the person that answered the first?
I answered the first.
Okay, Lily was, right?
Yeah.
Yeah, and the question was, for 0 less than less than t less than 60, there must be a time t, must there be a time t when v of t equals a -2, and -2 is a y? And you said, yes, there is. And then we started a conclusion. Since it's continuous, and v of 0 equals a -10, and v of 60 equals 13, so this y is below a -2, and this y is above a -2, so there's got to exist a what, Tucker?
An x value that equals -2.
Yeah, but we're not going to call it x.
It would be like a
What
V
are
of-
my x values called?
v of t.
That's a y value. -10, -15, -10, -7, -5, 0, and 13 are y
T.
values. It's my input values are my x values. But what is the variable I'm using for my input values?
T.
Right. There exists a time t, correct? There exists a t. Where does it exist?
Between 0 and 60.
Yeah. In 0 to 60, where if I plugged it into the velocity, it would have to give me what?
-2.
-2, and I probably should write feet per second because I want to get my points. Feet per second. Feet per second. Okay? Now, Bailey, you've got, here it was part 1, here was part 2, here Tucker did part 3. Part 4 is really short. What is it?
By IVT.
By IVT. And what's nice, they don't make you write intermediate value theorem. You know why? Because the word intermediate is hard to spell. And for some of us, even the words value and theorem are hard to spell. So you can get by with IVT. Everybody cool on that? All right, backside. And this is the one that I did in my notes. And I think Sarah did this one yesterday in the notes, if I recall. Am I right, Sarah?
Yeah.
Yeah. In fact, that was in the notes for 1.4 at the very end. Right? Didn't we come up with something like -3 and or -7 and something else? So I think Sarah did that. So that's in the notes. You can just copy that. So how much time do I have? We started at what? Noon?
Yeah, we have about 7 minutes.
Yeah, I'm supposed to let 7 minutes. I think we can finish this up. Okay. Now, a lot of times you get this. How to prove that a function is continuous at x equals c. And I guarantee you this is on the next quiz. This is on the next test. This is on every AP exam. What three things must exist? The three things are f of c exists. The other thing is the limit as x approaches c of f of x exists. Now, how do I know it exists? I know if it exists if the limit as x approaches c from the right of f of x equals the limit as x approaches c from the left of f of x. That's how I know it exists. And the last thing, so here's 1, here's 2. This is like 2a, and this is 2b. And the next thing I need, which is 3, is that the f of c is equal to that limit. That's what I have to show. So let's take a look at this. We are told that f of x is a piecewise graph. There are two pieces. To the left and equal to 2, the function is x squared plus x plus 1. So it's a parabola at 2 and to the left. When it's greater than 2, it's a line. So the first thing I have to do Ella Nelson is see if f of 2 exists. So I don't plug them into both places. I only plug it into one of those places. What part of the function can I plug 2 into, Ella Nelson?
The x squared.
Yeah, you can only plug it into here. Why? Because it says this is when if x equals 2, you got to plug it into here, not here, here. So if I plug it into here, Ella, I'm going to get 2 squared plus 2 plus 1. What does that give me?
7.
7. But, Ella, this is tricky. That's also the limit as x approaches 2 from the left. Correct?
Yeah.
Yeah. So I know this exists, and I'm halfway in figuring out what my limit is. So now I'm going to figure out the limit as x approaches 2 from the right of f of x. And where do I do that? I come down here. And this is a line. And a line is continuous, correct? So that means I can plug in 2 here. But when I plug in 2 here, I'm actually figuring out the limit from the right. Would you agree with that?
Yeah.
Because it can't be 2. Yeah, but it can be 2.1, 2.01, 2.001, 2.000000001. And it's going to get close to whatever 11 minus 2 times 2 is, correct? And what is that?
Yes.
And what is 11 minus 2 times 2?
7.
7. So that means the limit as x approaches 2 of f of x equals 7, which is also what f of 2 is, correct?
Correct.
There's my work. Is it continuous at 2? Yes, it is. Why? Because it exists, and that value is 7, and it has a limit of 7, and those two numbers are the same. 7 is equal to 7. Hence, it's continuous at the point 2 comma 7. That's what I show for work. All right, backside. Notice the backside, it showed exactly what I did. I just said, hey, when I computed this, these two things are the same. So what is due for me on Friday by 8 a.m.? These two problems. And that's, if you're going to take a picture, that's the only thing you have to take a picture of. You don't have to take a picture of any of the other stuff. So what do they want here? So I give you a table. I want your justification why this is true. I give you a table. I want your justification of why this is true. And the work that follows with it. Any questions on what I want? All right, so I'm going to stop sharing. I think that clears up what's due on Friday, right? It's not an over amount. Hopefully I've cleared up what continuity and what the intermediate value theorem is. Tomorrow I'll clean up any notes that I have to give you. I will also start, well, I'll even finish infinite limits and Friday. I'm going to clean up some stuff. You'll probably have some work time on Friday, I anticipate. And I got to make 2 adjustments. One to the 1.4.1.5 assignment, because I'm going to pick up some problems that I dropped on the previous, so you'll see that changes. And I have to change some scores in the quizzes, which is not only you guys, but it's also the other class. Okay, good thing that, William, I'm glad you're a detailed person. Do you want to be a doctor someday, since your dad's a doctor?
I do not.
You do not. Okay, what's your aspiration? Math?
I don't know yet. I'm gonna be totally honest.
Okay. You know what I wanted to be when I was a junior?
A lobster fisherman.
Yeah, you got it, a lobster fisherman. You know what my mom thought about that?
What did she think?
She thought I was nuts. You know what she wanted me to be? A
Lawyer.
pastor.
Oh, a pastor.
Yeah, that's not a good. That would not work well for me. I mean, you're on call all the time. I mean,
I
it's
know.
not like people.
24 hours.
Yeah, you got to pray. People don't get hurt. They're not in crisis at convenient times. I would have been. I have a friend who's a pastor, and it's like a lot of work. So, math, and how many people? I mean, they would be listening to my math problems. All right, people, you guys are done. All right, we will see you tomorrow.
All right. Thanks, Kurt. So just those 2 questions at the end of the orange packet.
Yep, that's it.
All right. Thanks. See ya.